A skeletal or line structure is a shorthand way that chemists illustrate the structure of an organic molecule. In a skeletal structure, the end of each line, each angle, and/or intersection represents a carbon atom. Hydrogen atoms are implied. We assume there are as many hydrogen atoms as needed so that each carbon has 4 bonds. Heteroatoms, which are any atoms except for carbon and hydrogen, are expressly written, although usually lone pairs are not included, and any hydrogen atoms bonded to a heteroatom are generally expressly written. Let's look at an expanded condensed structure as our example to draw a skeletal structure. To begin the skeletal structure, I represent each carbon atom as a dot. In the expanded condensed formula on the slide, there are 1, 2, 3, 4, 5, 6, 7, 8 carbon atoms with 6 carbon atoms in a chain and 1 carbon atom above the second carbon atom and 1 carbon atom below the third carbon atom in the chain. In the Lewis or expanded condensed structure, tetrahedral bonds are almost always drawn at 180 or 90 degrees, which is not accurate. Skeletal structures are more accurate representations of the bonds since tetrahedral bonds are drawn at angles, which more closely represent the 109.5 degree bond angle. You'll notice the 6 carbon atoms in the chain are drawn in a zigzag fashion, and the 2 CH3 groups are placed above the second carbon and below the third carbon atom, respectively. After each carbon atom in the expanded condensed formula is represented by a dot, I connect the dots with a line. The skeletal structure looks like a bunch of zigzags, but chemists know exactly what this means. Each end of the line represents a carbon atom. Each angle represents a carbon atom. And if we were to go from a skeletal structure to a Lewis or a condensed structure, we would add as many hydrogen atoms to each carbon as necessary, so each carbon atom has 4 bonds. On this slide, there are some examples of line structures. The first example has 1, 2, 3, 4 carbon atoms. The heteroatom oxygen is expressly written. Sometimes this hydrogen at the end is written if the last carbon is bonded to a heteroatom. Sometimes this hydrogen isn't expressly written because it is bonded to a carbon atom. The next line structure also has 1, 2, 3, 4 carbon atoms, and there's a double bond between the second and third carbon. Each carbon atom in the double bond has 1 hydrogen atom. The last example also has 1, 2, 3, 4 carbon atoms. The heteroatom bromine is on the second carbon atom. The carbon that is bonded to the bromine only has 1 hydrogen atom. When translating from a skeletal structure to a condensed or Lewis structure, add the hydrogen atoms last and add as many as you need so that each carbon has 4 bonds.